Hey everybody, welcome to video 5C here. We are in the part C of our module 13 section on trigonometry. The last time that we were together we did an activity where we discussed that anytime you know an angle, there are the built-in functions in your calculator, sine, cosine, and tangent, right? These middle buttons right here that allow you to feed in an angle and come out with the ratio of the sides that is true for every right triangle that has that corner angle. And we actually drew those triangles in our activity, if you remember. So it didn't matter the size of the triangle, the sides are always in the same ratio. And when we talk about the sides, we mean opposite, adjacent, and hypotenuse, depending on which two you choose. All that matters is the size of the angle. So because they're all similar triangles, we know we can set up a proportion. And so the work that you're going to see with the examples with the algebra, with the examples in this video, are going to be using the idea of proportion. And as you know, of course, that's using our LCD method to solve. Okay, so here's a typical, in example 1 here, here's a typical setup for a right triangle trig problem where you are, as you can see, given the angle value in the corner, okay, and you are given two other sides that one is an unknown and one is known, okay. So what we're going to do is we're going to, just like we did on our worksheet where we identified the ratio depending on where we were sitting in the triangle, we're going to sit ourselves right here at angle A, and we're going to label the two sides that are given here. Whether it's a variable or whether it's a given value, it doesn't matter. We're going to label those two sides with where they are in relation to this angle A. So our 7 is a adjacent leg right to the angle. So we're going to make 7 my adjacent, and X is the side that is opposite the right triangle from that 36-degree angle. So that's my opposite. And then we're going to think back to our little mnemonic of some old horse caught another horse taking oats away, remember? SOHCAHTOA. And of course, remember, we chunk that in our brains in 3 letters at a time. So I'm going to ask myself, with this particular picture here, what 2 letters of opposite, adjacent, and hypotenuse are being used? Well, you can see opposite and adjacent is in the TOA part of SOHCAHTOA, okay? So that tells us that as we set up the proportion equation here in this example, that we want to start by using the tangent ratio, okay? So the tangent of what angle? Well, we're given the 36-degree angle, okay? And that is going to be equal to its opposite side, which currently is an unknown, all over its adjacent side, which is 7, okay? So we always are going to want to solve this by just going ahead and taking our calculators. And with our calculators, we can find a decimal approximation for the tangent ratio for 36 degrees. The sides for a 36-degree angle should be in the ratio 0.7265, and we are going to take this out to 4 decimal places like we did in our activity, so that it's to the nearest 10,000th. Before we have a straight equal sign back here, as soon as we take a rounded value from our calculator, we're going to change this to an approximately equal sign, so put a squiggle equals there, and we're going to keep our same x over 7 in our work. Okay? So this is a proportion. We've got a fraction on the right-hand side. Let's create a fraction by putting a denominator of 1 on the left-hand side as well. And because we have just 2 very easy denominators, 1 and 7, our LCD is just the 7, right? So we're going to go ahead and introduce that on a multiplier on both sides of the equation, because when we multiply by the LCD, it's going to cancel out any of the denominators, common factors, okay? And in this case, it actually kind of solves the problem for us. Our x is going to be approximately equal to 7 times 0.7265, or we're going to get approximately 5.09. And do keep in mind what you're being asked to, excuse me, how many decimal places you're being asked to round to, and that's to the nearest hundredth or to 2 decimal places here, okay? I did also want to just bring to your attention here, as you can see, this little screen that I have a screenshot of your calculator, is a reminder to you to make sure that when you press your mode key, you're seeing the settings that are in front of you, specifically that it's in degree mode. Because you guys, if you did not get this decimal when you pressed tangent 36, if you got something else, if you didn't get the 0.7265 coming out of your calculator, then that means you were likely in radian mode, which is not where we want to be. So be really careful with your work there and make sure on the calculator you're in the right mode. All right, so here's our answer, and sorry, I meant to circle that, not give us a highlighter there. Okay, so 5.09, let's see if that makes sense in the picture, all right? Does it make sense that 5.09 is that opposite side? Well, it's opposite a 36-degree angle. The adjacent appears to be longer. I wonder what the angle across from angle 7, the side that is a length of 7 would be. Well, we can do a quick little subtraction, right? And we can see that angle B should be 54 degrees. And that's a larger angle than 36, so it makes sense that the side across from it is also a longer side than the side across from 36. Just kind of keep that in mind as far as whether the answer you come up with, the decimal that you come out with on your calculator, makes sense or not. All right? All right, so let's go to the next example. And we are at example 2. We're still using the idea of SOHCAHTOA, okay? So let's rewrite that little mnemonic for ourselves. Notice I'm leaving some space in between the 3-letter chunks there, so that I can kind of think of that way. So always, again, put yourself at the corner that is the given angle in the picture. So I'm at angle W, all right? And I'm going to label the sides that I have been either given or given a variable that I need to find in relation to that corner W angle. So what is 12 in relation to that angle? Of course, you guys, that's the opposite. And what is X? That's always the hypotenuse when it's across from the 90-degree angle in the triangle. So if we have opposite and hypotenuse, that means we are going to set up a sine ratio proportion, okay? So we're going to start with the sine of 63 degrees is going to equal the opposite, which is 12, over the hypotenuse, which in this case is my unknown, okay? On your calculators, you're going to get the sine of 63 degrees out as the decimal 0.8910, and that is going to now be an approximated value, so put your squiggle equals there, is equal to 12 over x. Again, it's a proportion, so make it 1 by putting a 1 underneath that left-hand fraction. And our LCD this time is actually going to be the variable x. So let's introduce that as a multiplier in the numerator on both sides of our work. You can see what happens is that the x cancels out on the right-hand side, but it's now introduced on the left-hand side in the equation. So we have this 0.8910 times x is approximately equal to just 12. What's our final step to get x alone? Well, we have to divide by the multiplier that's in front of x, so that's divide by 0.8910, and we're going to do that to both sides of the equation. And when all is said and done on this one, we are going to get that x is 13 and 47 hundredths, or 0.47. go back to the picture and make sure that makes sense, right? 13.47 for our answer is the hypotenuse, and we know that in reference to the opposite that we were just given, of course, it needs to be the longest side, right, in this triangle. And if the opposite is 12, then my hypotenuse at least has to be bigger than that, and it is. So we have an answer that hopefully makes sense. All right. So that's it, you guys, for the video today. Real quick and short here. You're just going to do, as your turn here, the example 3 on this page. So you're going to do that one. And then just one final question that I would ask you once you're done with that, your turn. On the back side of your notes sheet here, your WISC form, watch, summarize, question, remember WISC, is a question that I would pose to you, just kind of like a preview of coming attractions. On the back side, we see this little man here is questioning and kind of scratching his head. What I would just pose to you as a question would be, I wonder what happens because in every single one of the problems on the front side of your note sheet, we were looking for a missing side. What happens if we have a diagram where the unknown value is an angle? That's a good question. You're just going to have to be patient and wait until our next video, 5D, to talk about how we go backwards from knowing the ratio and finding the angle instead. All right, I'll see you guys next time.